Hello, ni hao. Can you see this okay in the back? Can you read it? Okay, we will start. Thank you for having me. I'm very honored. I'm very happy to be here. And I will just do what I do, programming. So I will talk about structs in Swift. And first we will have a little bit of a look at what structs are. And then we take an existing project and we will refactor it from classes to structs. So let's make our first struct. So this is a person struct. And it has a name. And it has an age. And now we can create a person. It's very simple. So we can say Chris.
Oh, the problem.
Yes, this is better. It's the magic of technology. So we can create a struct, and we can put in a name and an int. So for example, I can put in my name and my age. And now we have a struct value. And because it's a struct and because we defined it using let, we cannot change it. So if we try, for example, chris.name equals test, we get an error because its name is defined using let and Chris is defined using let. So we can click the error button and now it changes name to a var. But still, we cannot change it because it's a struct. If you see a struct like this and it's defined using let, you can never change it ever. So we can click the button again. And only when it's a var, you can change it. So with structs, everything that's let, you can never change. Everything that's a var, you can change. And we still also cannot say age++ because age is defined using let. So if we change it to a var, now we can change the value of the struct. And it also works if you have nested structs. So let's create a nested struct. So we create an address struct, and then we say street, string, and the person gets an address. So now we need to add the address here. Street, let's say college, road. Now, if you say chris.address.street equals new street, this works. But if we change the struct to a let, it doesn't work. So you cannot change the properties of the struct, but you can also not change nested structs. If you change a nested struct, it means you change the entire struct. So only when the entire struct is a var, we can change it. And we can test this also. So we can add a did set and then print something. Value changed. And if I delete these two lines, you will see, let's see, that even if we only change the street, the entire struct will change. So everything changes. And this might look like a limitation, but it's actually very nice, and we will use this in the refactoring. So let's move to the refactoring. I will run this game. So I made a small game. Actually, I did not make a game. I only made the model of a game. So I did not make any UI. So it doesn't look like a game, but it's only the game model. In the game model, there's a player, and a player has health, and inside the health there are points. So this is my game. You can click add health point, and you get one more health point. You can click it a couple of times, and you get more health points. And there's a button to reset all the health points. And if I add health points and then I exit the game, and I restart it, it saves the state. And it saves the state in NSUser defaults. So the state is persistent. OK. So let's look at how this is built. And actually, this code is code I took from a client of mine. I helped them refactor their code to structs. So here's the game. It's a view controller. And this is where we create the model, var game equals game. And then in the view did load, we create a button. I made a small helper function that creates a button saying add health point. And then when you click it, these two lines get executed. So if you click add health point, it says game.player.health.points plus equals 1. And if you click the reset, it sets game player health points to 100. And then it updates the label. And updating the label is just as simple as setting the navigation item's title. OK. So let's look at the game class. This is the game class. And it has a user defaults property. So this is, in a way, it's a nice design. The user defaults gets injected into the game. It's like dependency injection. So if you initialize a game, we set the NSUser defaults. And then we create a player with the same NSUser defaults. So we pass the dependency on to the player. And then we load. Currently, the load and save are empty. But we will fix that later. And let's look at the player. It's very simple. It has a name, which is a string. And then if you change the name, it calls the save method. So then if you change the name of the player, it saves it to the NSUser defaults. And it has a health property over here. And again, it stores the NSUser defaults. So if you create a new game, it stores the NSUser defaults. Then it creates a health object. And then there's the save and the load. So the save, if it sets the player name in the NSUser defaults. And the load loads the player name from the NSUser defaults. So it's very simple so far. Let's look at the health class. It's also not so complicated. It has a points variable, an integer, and we start with 100 points in the game. And it has a did set. So if anybody calls health.points equals, then this code will execute and it will save the health points. And it works in the same way as the player. It has the NSUser defaults. It has a load method, which loads the health from the NSUser defaults. And it has a save method, which saves the health to the NSUser defaults. So this works. We can open the tests. Let's see. Here we go. So there are some tests. And let's see if they run. I hope so. Test succeeded. OK, good. So here we have a test for loading the health from the NSUser defaults. We have a test for saving the health, increasing, setting the player name, injecting the health. And we will look at these tests in a little bit. Before we start the refactoring, let me say there's a few problems with the code, I think, that are problems. So one of the problems is that everybody knows about the NSUser defaults. Every class gets the NSUser defaults, and everybody knows about it. And this is a really big dependency for me. And I don't like that. I think it would be nice if we can remove the dependency. And the other thing is that if you look at, for example, this load health test, there's a lot of state involved. So somehow we're testing that the objects are connected in the right way. So we load it from the NSUser, or we create the NSUser defaults, we set an object, then we load the health object from the NSUser defaults. It's a little bit complicated, and everybody knows about the NSUser defaults. So that's what we're going to try to fix, and we're going to do it in a few small steps. There's one more problem, and that is that the test is hard to create. So every time we need to create a defaults mock, and if we look at this, it's a subclass of NSUser defaults, and a subclass is already a bad sign in my world. So I try to not make a subclass whenever I can. So we need to subclass NSUser defaults here, and then we need to override object for key and set object for key. I think that's a little bit problematic. So hopefully we can fix that as well. So the first step is to create a type alias. So let's do that. Go back to a view controller, and let's create a type alias. And then we will continue from there. So we can do something like this. So we can create a storage type alias, and it's really just NSUser defaults. So I'll copy and paste it. And now we can search for NSUser defaults and replace it everywhere. So this one, let's see. This one will be storage. This one will be storage. This one, this one. And this will help with the refactoring. And only here we keep the NSUser defaults for now. So let's see if this is still working. I think it still compiles. OK, build succeeded. So that's the first step. Now what we can do is take the parts that we use from NSUser defaults, because we only use object for key and set object for key, and put it into a protocol. And then we isolate the dependency a little bit. So I have the protocol here. So this is the protocol. Storage. Now we can remove the type alias again. Here it is. So we can delete it. And let's look at the protocol. So the protocol says it has two methods, object for key and set object for key. And these are exactly the same as NSUser defaults. So what we can do is we can make NSUser defaults conform to storage without doing anything, because it already has those two methods. And hopefully, our code will still compile. Build succeeded. That's good. And now let's try to run our tests. Build succeeded. It's exciting if the tests succeed. It's testing. This is waiting. Something is happening, at least. I think my computer is very slow today. Oh, we can continue. I think the tests are still working. We'll make another change, and then hopefully the test will still work. So what we can now do is we can remove this subclassing. So now in our tests, we don't need to know about NSUser defaults anymore. And that means that we can also remove override here and here. And this is a good thing. We sort of isolated that dependency. We have NSUser defaults in one place in our code, and in the rest we're using our protocols. So it's, in a way, it's cleaner code. So let's run the tests again. Oh, build failed. This is exciting. So now, let's see, what is the problem? If we go to the health class, there's something wrong. Argument type defaults. Right, so the only thing that we now have to do is to say the defaults mock is storage. And we can do this because we have these two methods. Now hopefully our tests run again. This looks better. Let's see if the test build. I don't know what's wrong with my computer. It's interesting. Maybe I'll quit Xcode. This is the demo god. We'll restart Xcode. So the trick to live coding is to practice a lot. And I practiced a lot, but never did Xcode crash. So it's this one, this one. So hopefully our refactoring worked. Let's run the tests. Now I think it's going to go faster. And then if it doesn't work, we can just do the refactoring on our own. I have practiced, so I know how the refactoring goes. Something is wrong with the tests. OK, well, we can refactor it slowly by hand. The tests are apparently not working. OK, so let's go to our health class. what I want to do is I want to create a second initializer to the health class and initialize it with a dictionary. And this, instead of the storage, so I want to load the health data from a dictionary, and I also want to be able to serialize it to a dictionary. And maybe this will allow us to get rid of the NSUserDefaults dependency for the health class. So let's try that. So we create a second initializer, and we call it dictionary, and it takes a dictionary from string to any object. And instead of reading the data from the NSUserDefaults, now we read the data from the dictionary. So what we need to do is we can say points equals dictionary points. So it tries to read the points from the dictionary. Because it's any object, we need to cast it. So we need to say, OK, try to make it an integer. If it's an integer, then use it. Otherwise, we start with 100 points. Now, to make sure the code compiles, we need to set something for the NSUserDefaults. So I'll just use this for now. We will delete this line. It's still testing. So now we have our initializer for the dictionary, and we can also add a serialize method, and which is the opposite of the initializer. And again, once we have that, we can get rid of the NSUserDefault. So let's create the serialize. So this is a function serialize, and it returns a dictionary, string to any object. And it's the opposite. So we create a dictionary that has points in it. So we just return a dictionary with points, and then we can use self.points. And because it's Swift, we can actually just write points. It's the same thing. OK. So how do we use this? Well, now we have to use this somehow in our player class. So the first thing that we can do is we can now hopefully get rid of the NSUserDefaults. So let's try to delete it and see what happens. And now Xcode will help us to fix everything. So we can delete this. Actually, we can completely delete this initializer. So let's delete it. We can delete this line that we just wrote. And we can delete the load and the save. So gone. OK. Now, of course, our code breaks. If we would have had the tests, then we would have had failing tests. But today is not the lucky day. So now we need to create this health in a different way. So we need to say something like health equals health. And then it wants a dictionary. So let's write dictionary. And then we need to create this dictionary from somewhere. So as a first try, we load it from the NSUserDefaults. So we say like dictionary, string to any object, equals user-defaults, object for key, health. So this loads the dictionary from the NSUserDefaults. And now we can delete this load. And see, we need to cast this. Any object. And then we can remove this type. So now it might also be nil, the dictionary. And in that case, we just pass on the empty dictionary. If there's no dictionary to be found because it doesn't exist yet, then we just pass on the empty dictionary. So let's see if it still builds. Build failed. Exciting. So now this save method doesn't exist anymore, so we can delete this one and this one. So hopefully it still runs. It's not going to save it yet. Let's see where we have our simulator. It will open up, and it will, at least it compiles. That's already a very good sign in Swift. Huh. Interesting. Quit the simulator, invalid device state, run again. So you can see that the health class is now very simple. It only has points, it has an initializer, and it has a serialize. And it's easy to understand. You don't have to think, OK, did I set the NSUserDefaults? Did I call the right methods? So it's still working. what we can do now is change this class to a struct. So let's try that. So far, so good. We get 2 errors, so let's fix them. So the first thing is now, here we have our public let health. Because it's a struct, we cannot change it, so we have to change this to var. So now it's public var health, and now people can change it. We can delete. And let's try to run it and see if it still compiles. Build succeeded, so that's a good thing. It still works. It doesn't save it yet. So how do we save this? Well, we can use the same trick as before. In the variable, we can just say did set. And then we call save. And inside the save method, we now need to store the health struct. So how do we do that? So it's the opposite of the initializer. So we just say user default set object, health.serialize, and then the key, we just use health. It needs to be the same key as up here. So now hopefully, if we did everything correct, it will still save. Let's see, add health points. So we're at 111, quit the app, start it again. Okay, it's saved. With the tests, we would have seen that the tests would have succeeded, but alas. Okay, what we can do now is repeat the same trick, but with the player. So instead of player being a class, we can make player a struct, and then we can do one did set on the entire player. So then the player will also become very simple. So let's try that. First, we create another initializer, and it takes a dictionary, string to any object, and we need to set the health and the player name. So the health, the first thing we need to do is to look up the dictionary for the health. So what we can do is say let health dictionary equals dictionary health, and then hopefully it's a string to any object. And then we say health equals, create a new one. Great, autocomplete stopped working also. This is exciting. You get to see my typing skills. So now we can create a health struct. And we need to set the player name. So there we say name equals dictionary name. If it's there, if it's a string, then we use it. Otherwise, we use the empty string. So let's see if this builds. Build failed. This needs to be a double question mark. And now we forgot, there's one property that we didn't set, that's the NS user defaults. So for now, we set it to standard user defaults. And we will delete the NS user defaults also. So build succeeded. That's a good thing. This means we can delete this initializer. And let's also just straight away delete the user defaults. So this talk is all about deleting code, which is a good thing. In the save method, now we will sort of move this logic out of the player struct, so we can delete this one. And instead, we now need to have a serialize method, just like we did for the health. So we can say serialize, and it's also returning a dictionary. And this is, again, the opposite of the initializer. So we need to return a dictionary with the name, which is name. And we need to return the health, which is health.serialize. So now we don't need this line anymore. And we don't need these setters anymore. And we can delete this as well. So this is nice, right? It's getting very clean. Now the only problem is the game. And this is where we actually have our NSUser defaults. Now it will only be in this game class, so it's only in one spot. So we sort of took that dependency that was in the game and in the player and in the health and moved it out of the player and out of the health, and it's only in the game. So let's try that. Now, here we need to read the player state from the NSUser defaults. So we say player dict equals defaults object for key player as. So you know how to type this now. It's everywhere, it's the same code. And now we create the player with the dictionary. Player dict. And maybe it's empty. And we can delete the load function. And in the save function, now we store the player serialization in the NSUser default. So it's the opposite. So now we say user defaults set object player.serialize, and then the key is player. We are not calling the save function yet, and because we are dealing with structs, we can add a did set here. And if you remember from the first example, if you change something deep inside the struct, for example, player.health.points, it will trigger the did set of the player because it changes the entire struct. It creates a complete new version of the struct. So now this needs to be a variable. And hopefully it will still work. So let's build this. Build succeeded. Let's run it. It runs. So we can add health points, we can reset it, and we can quit the app, restart it, and hopefully it will restore the health points. Oh no, we did something wrong. Interesting. I didn't expect this. I wish the tests were working. Let's see if I can debug this. This looks okay. This looks okay. This looks okay. If we had the tests, we could see what would be working. I don't know what's wrong. We can print the player dict. Did anybody see it? If I made a mistake. So this looks okay. Yes, we need to change it to structs. That's the thing that I forgot. Thank you. So this is now a struct, and now it will work, hopefully. So store it to 109, and restart it, 109. So now it's working again. Thank you. Okay, so let's look at our model code now. Before we had this complicated health class, which had an NSUser defaults and a load and a save, and what you did not see is that it was also hard to test. You need to create some kind of custom mock for the NSUser defaults, and you need to make sure that everything is connected the right way. Now we have a health struct, so it only has a points variable and an initializer and a serialize. And there is no NSUser defaults anymore. Maybe we can initialize this with JSON from the network, or maybe we can load this dictionary out of core data or Realm. And it's the same for the player. Before we had a load method and a save method and an NSUser defaults, and that's all gone. Now we have one initializer and one serialize function. And you can even do this with structs that you already have. So you could even do it like this. Say extension player. And this way, it's even more separated. So the player now is very, very simple. And then you say, well, okay, it's very simple, but I add these things later on. And I think it's a clear win. So, of course, this is a super tiny example, but if you have a larger game, then this is very easy because you can quickly create structs, and you don't have to think about the did set. You only have the did set in one place, and you only have the user defaults in one place. So you don't need to do all these things in your head and write all these tests. You can just depend on structs. there's also a downside. So before, with the player class, we could do individual properties. So we could only store the health points, for example, or only store the name. Here, if we change anything in the player, we have to serialize the entire player. In this case, it's not a problem, and in the practice, it's often not a problem, but sometimes it might be a problem. So sometimes it might be nicer to have a class than a struct. But I think as the Swift community, we should start exploring structs, especially if we come from Objective-C, where everybody only uses classes. I think we need to explore the possibilities. And I think this is one possibility that we can explore together and see if we can use more structs in our code. So that's all I have to say. I would be very happy to answer any questions. If you want to ask your question in Chinese, please do. I think somebody can translate it. Thank you.
Structs used as a model. Yeah, if I have many methods, I should use class or struct. I have many methods to control the. If I use many methods, it's not different to use class or struct.
No.
Have many methods.
Yes. So you are asking, you now have classes with many methods.
Yeah.
Can you use structs?
So now I should use the struct or class.
So it depends. So if you have something that changes a lot over time, then maybe you might want to use a class. If it's really just simple values like a player or a user or an article, then it could be nice to use a struct. For some things, you want to use an object. For example, if you have a window, because there's only one window. And for some things, it might be nicer to use a struct if you have your model data. So I think that's the kind of question you can ask yourself. Is this more a model, or is this something that's on the screen, or has a resource?
Okay.
是不是当一个类的属性就是经常发生变化的时候，是不是用 structs 会比用 class 性能要高一些？
So the talk was very short, so I could talk about structs for 2 days. But so I could not possibly explain everything. So you can use as many properties as you want. There's also one other difference with structs and classes. A struct is usually on the stack, and a class is on the heap. So structs can sometimes be faster and sometimes be slower. If you change a struct, and you have many properties, and you have maybe many structs inside, so it's a very large network, then what happens is the entire struct gets a new value. But they did it in a very efficient way. So even though you think that it copies everything, it only copies what it really needs to. So you can definitely use a struct with many properties if you want to. Yes.
OK， 所以说如果它的属性特别多，然后我可能改变的只是其中1、2个的时候，您推荐的是 structs 还是 class？
So if I have too many properties, is that right? Would I still be using structs or class? Is that the right question? If you have too many properties,
I think it doesn't depend on the number of properties. So you can use either one.
OK。
Or both. Yeah.
OK, thank you.
Sorry.
So a few of the properties will vary very often. Will that be still efficient to use structs?
Sorry?
Only a few of the properties will vary very frequently. Will you still use structs or class? So
I'm not sure if I understand.
So he's going to be mutating the properties very often.
Yes. It doesn't matter, I think. No, it should be the same, because so what happens if you create a new value of the struct, it sort of copies everything, but only, it does it in a smart way. It only copies what it really needs to copy, and the rest is the same. So in the end, it's almost the same efficiency. So if you're wondering about speed, it's similar. And yeah, you can use both. Yes.
All right. Now it's my turn. So I'm sorry, I didn't quite see the implementation of the serialized method of the health struct.
Yeah.
So I want
we can go back. Here's the health struct. So it really just creates a dictionary out of the.
So you're not interfacing with the NS user default in any way?
So the health struct only knows, if you give me a dictionary, I will initialize myself, and it knows I can create a dictionary. It doesn't know anything else. And it's the same for the player. It knows, give me a dictionary, that's over here, and I will initialize myself, and it knows I can give you back a dictionary. It's the only thing it knows, and all the user defaults logic is now only inside the game.
So when did you exactly save to the disk?
That's in the game. If we change the player, so that's over here, we call the save method. And this is where we save to disk. So it's only one call. And even if you change something deep inside the player, it will change, it will save to disk.
But say if you have a very complex struct and you have to archive it using NS coding, that will break because it's not a subclass of NS object.
Yes,
so what's your solution to that?
You cannot use NS coding with structs.
Then how would you save a very complex?
So you have to break it up into little structs and then do it, for example, like this technique. So you can easily add 100 structs, and you need to implement the serialize in the init yourself. Or, yeah, with NS coding, it only works when you have a class. So there you also probably need to implement the initializer, or what's it called, awake. You need to implement all these methods yourself too. Okay. And with structs, if you really want to, in Swift, you can use some kind of introspection. There's the mirror type, but I haven't really tested that too much. I only tested it a little bit.
Okay. Thank you so much.
嘉宾你好，我就用中文问问题了。我这个英文不是太好，听了一个大概就是连蒙带猜，意思是说，用 Struct 的它的这个改变变量的时候会更加的那个方便和快捷。那么我想问的就是，那么 class 它存在还有什么意义吗？或者说能不能把这个 struct 给结合到 class 里？就是说 Swift 这门语言是追求更加简洁、更加安全、更加方便。就是能不能可能是 struct 结合到 class 里？谢谢。
Yeah, I think what we have to do is learn how to use structs more. We need to explore this. I think if you use only classes, it's okay. It's fine. We did this in Objective-C. It's going to work. So if you're insecure about structs, you don't have to use them. You can use classes and it's okay. But as you saw in this example, if you learn how to work with structs, they can be simpler. So that's what I would advise. So just write classes as you did before, because we know how to do this. We know how to do object-oriented programming. We have done it for a long time. So it's okay. Just use object-oriented programming, but maybe use some structs in some places where you think, hey, maybe this is easier, and just experiment with it slowly. And I think this way we can move towards structs, because what I can promise you is that a lot of the things are easier with structs once you understand them the right way. It takes a while to learn. It took me a few months to really understand how structs work, like to deeply understand, and this is a bit painful. With classes, we know this, we've done this for such a long time, and we're good at it. With structs and with protocols and with a lot of things in Swift, everything is new, and it's a little bit painful, and you will work in a slower way, and this is normal. We have all had this. So that's maybe the best advice I can give, is slowly try to write some more structs and see if it works, and maybe it works and maybe it doesn't, and treat it as an experiment. This is no more code writing today. This is something we need to learn, and it's okay to make a mistake, and it's okay if it doesn't work for you. If you want to use classes, it's completely fine, but try it and play around. And I think also later today in the talks on functional programming, for example, we will see how we can use functional programming, and structs work really well with functional programming. Yes.